quadratic. -2, -1, 0, 1, and 2. Make sure when you put in the calculator, 4, 1, 0, 4. Up 2, you add 2 to the y values. Down 2, you subtract 2 to the y values. When you reflect it over the x-axis, you use the opposite sign of your y values. So if they were positive, they become negative. If they're negative, they become positive. Right 2, you'll add 2 to your x values. Left 2, you'd subtract 2 to your x values. The harder one, vertical stretch and vertical compression, it's telling you what to multiply your y's by because vertical is y's. So you're using these same parent function numbers over and over again, and you're doing these little transformations to it. Add 2 to y. So I got 6. So I multiplied by 3 to my y. I did 4 times 3 to get me 12. 1 times 3 to get me this 3. 0 times 3 to 0. 1 times 3. That's how you do vertical stretch and vertical compression. All right. Up 2, you're adding 2 to your y values. So 0, 1, 2, 3, 4. Up 2. If it helps you, write them. If it doesn't, no. Because a lot of these, you just figure out where the center point moves, and then you just keep the pattern up 1 over 1 go. So down 2, and you just graph it.
Well, how many did you buy, you fat kid?
Bro, I had her $1 and she was like, it says 2 for $25. And I was like, God dang.
Down 2. Reflect over the x-axis. So if you were at -2, -2, it would reflect up. So it'd be -2, +2. That's what it means by the y's change signs. So it was -1, now it's +1. So now you're just having a slope go down.
Fair enough. What you?
Right? Add 2 to your x value. Left, subtract 2 to your x value.
Your pants. What, Lorax?
The harder one is your vertical stretch, vertical compress.
Meter stick. Zane.
I thought a meter and yards.
Multiply it by 5.
No, meter and yardstick are different.
So
A meter is like
10,
2 inches
5.
Your hair's very bouncy.
You saw when he almost lost his hardcore mic.
What is what?
His hardcore mic got broke.
-2, -10 does not fit on the graph, so don't graph it.
Well, good for you. It's like you never even met.
Just make sure you go off your graph before you hit 2. Go off your graph before you hit -2. Try to make it look more like a straight line than mine. Mine does not look very straight. Thanks. Then a fifth. You get -2 over 5, -1 over 5, 0 over 5, 1 over 5, 2 over 5.
I forgot how to make it.
Control Enter. Yes. That's very squeaky. Why is that so squeaky? So with writing equations, when h is just a number. So when I plug in x plus h, I'm moving the X. When you move the X, you're moving either left or right. So if you're plugging inside, it's going to go left or right. And inside is opposite of what you think. So plus H is actually going to move left H units. However much, like left 5, left 3, left 2, however much that is. Minus will actually go to the right that many units. Because remember, inside is your X's, so that's how you know it's left or right. Outside is your Y, so you're going to take your Y and add K. So if I take X and I add 2, my Y value, and I add 2, I'm going to move my whole graph up 2. Or up H. I'm sorry, K. Whatever K is. However K many units is. I'll get them.
Thank you so much. I didn't mean to. Hey, Haley. You smell bad. You smell like beef and cheese and beans. Baked beans.
All right. A in front is your dilations or stretches. And we're only going to have to talk about vertical in this class. Pre-cal, you'll talk about horizontal. But luckily, we only talk about vertical. If your number is greater than 1, it's going to vertically stretch your graph.
You're so sassy.
Or dilate. Same thing. By A. Whatever A is. If it's less than 1, it's going to vertically stretch. No. Compress. I said stretch. Right? Compress. And that'd be like your 1/3 or 1/5 that we did on the front page. If you do the negative of your whole graph, of your whole function, that's going to be reflecting it over the x-axis. And I know this box is in here, but if you plugged in a negative x, it would have reflected over the y-axis. All right, with this equation, I usually write it out a little different.
What's so funny, E-Money?
I'm in a negative.
E-Money, do you watch Christmas movie boxing?
If there's a negative,
Yes, he does. We'll go with that, yeah.
Can you beatbox for us, E-Money?
Absolutely not.
it reflects over the x-axis. This is your reflection equation. So if it's absolute value, then you have absolute value bars here. But I can change this to a quadratic transformation equation. Instead of having absolute value bars, I'd have parentheses squared.
Thick boy base.
And it's the same exact equation, except it's parentheses squared. To make it a cubic, I'll have parentheses cubed. Still, all this stuff is all the same though. Left if it's negative, right if it's positive, positive if it's up, negative if it's down. If it was a square root, instead of an absolute value bar, would have a square root sign with the h on the inside of our square root. So a cube root would have a 3 on the radical. So this transformation equation works for all of your equations.
Why are you
This
so
one's just
sus?
absolute value because it has absolute value bars.
Miss Rhodes, why are you so sus about it?
What are you confused?
Like in the green, the B and S.
Vertical stretch if it's greater than 1, vertical compression if it's less than 1. Inside my bars or inside my function, because this is the absolute value function, so my key feature is absolute value bars. Positive means left, negative means right. Outside your absolute value,
What is
plus
BS?
is up, down is negative. So inside your absolute value bars, remember inside you go left or right. and it's opposite of what you think.
Then what
So
you just
positive is to the left.
toss me one.
Negative is to the
Or the right.
the right, opposite of what you think. So
Oh, that's the answer.
that's the answer.
Thought we were gonna do that.
Good for you. Look happy.
So if I put this in the calculator, the absolute value of x will look like this, and then this one would move this graph left 2.
Who do you like, E-Money? Like, for real. Bro.
Plus 2 on the outside,
Play the
Up
video.
down 2.
Your ears very bouncy.
2 in the front,
Let's see.
vertical stretch, because it's greater than 1. It's a vertical stretch by 2.
And then for the half, it would be
Vertical compress, because it's less than 1 by a half. So I'd multiply all my y values by a half. And then negative in the front,
Bro.
reflect over x.
What are you talking about? Zane, I think you're seeing things too. You're
And I just made one up for 8, just to see it as hard as I possibly can go, what everything would mean. So
it's so funny, bro.
our 4 transformations. I don't care what order it is. The negative is going to be reflection over x-axis. Inside plus 2, left 2. I forgot the 3. So it's a 3, not a negative 3. The negative is your reflection. Then the 3 is your vertical stretch. And then the last thing, down 5. In any order, those are just all your transformations. Plus 2, up 2, is that inside your parentheses or outside? Outside. So it'll be x squared plus 2 on the outside. So if you were to graph it, there's your parent function. Up 2. And move that graph up 2. To move it down 2, minus 2. To move it left and right, you want to be inside your parentheses, inside the squared.
Creamy peanut butter.
Remember, right is negative. Right is negative. Left is positive.
Money.
Inside your absolute, just inside your parentheses.
I'm double vaccinated.
So everything I just wrote.
Bro, he said, what's hard about this?
Writing the equation.
Wait, how are we supposed to write the equation?
That's everything I just explained.
You didn't tell me that.
So outside my parentheses, outside my squared, plus 2 is up. Down 2 is negative. Right 2 is inside. And then vertical stretch is in front of. That's the A of your equation.
Oh, what the fluff.
reflect over negative. I can go back up in a second. But just like the absolute value equation I wrote, now it's the same equation, but it has parentheses squared. Everything still means the same thing, but since it's quadratic, it's parentheses squared. How do I change this transformation equation from quadratic to linear?
You divide. Sleep.
How do I change this equation from quadratic to linear? Like what makes these equation quadratic? What makes these all U-shaped?
It's the square.
The squared. So to make it linear, you don't want the 2. Linear means it has an exponent of 1.
You made that
Like-
seem so hard.
You don't put an exponent of 1. That's just weird. You just leave it.
Made that seem
Leave it
so
normal.
hard.
I did?
Yes.
Thought I made it easier. So now this is the transformation equation for linear, just without a square. And we'll write the equations. So up 1. I'm tired of writing f of x. I don't know about you, so I'm just going to go back to y. Y equals. You can keep writing f of x. It's fancy.
You're so sus about it.
So x plus 2. X minus 2. Negative x. Negative is what reflects it. Where the a is negative. Right. Right is usually on the inside of your equation. Minus 2 in parentheses, but those parentheses don't do anything. So you can actually erase those just because they don't do anything, which makes the linear one a little confusing because down 2 and right 2 are the exact same. But if you notice, the graphs are the exact same as well. That only works for linear. That just happens on linear. So left on the inside,
Zane, you're so cringe.
add 2. Vertical stretch,
So are the
5x.
linear functions easier to figure out?
I think so.
How did you figure out?
I keep just going back to this. Negative a x minus h plus k. A is vertical stretch, vertical compression. So that means your number has to go in front of your x for vertical stretch, vertical compression.
I'm just.
We gotta do more. The more we do, the easier it gets. Hopefully.
So you just put them in parentheses when you're going right to left.
Yes. And if it's quadratic, those parentheses would have a 2 on it. If it's cubic, those parentheses would have a 3 on it. If it's absolute value, it would be the square root.
Boy.
Remember, with your square roots, you're not going to use negatives because you can't take the square root of a negative.
Hey, that hurt.
So you start with 0. Square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. I think this is an 8 by 8 graph, so you won't be able to fit 9 too. But you at least know where it's going. So you're not guessing where your arrow goes. So your transformation equation for square root, y equals the square root, and a is in the front of the square root symbol. The h is on the inside of your square root, and the k is on the outside of your square root.
Yeah, I don't be understanding this at all. This is kind of hard.
So if you're translating it up, is that inside your radical or outside? outside. Outside's where you go up or down. So you have the square root of x plus 2.
I remember doing this in like Algebra 1, but
This review still.
it was like really easy, but it's kind of confusing right now.
Well, that's because we didn't do it with stuff. Like, we didn't do the equations.
Yeah, we did. We did the equations, but like, I feel like
We just don't
explained weird.
I was just told to like translate, dilate, rotate. I was never told to make the equation.
Yes, we were definitely making the equation.
No.
So you're
Yes,
adding 2 to all your y values still. You can still do the table, or you can now graph your equation and move those all up too.
Show you the world. Chupapi Muñano.
In your calculator, you have the square root of x. And then the next one is what? Left 2? No. Down 2. So it'd be minus 2 on the outside. Moved it back down 2. And if you want to see your table on my calculator, you do menu, table, split screen. And there are your points. Remember, you can't do negative points, so it's going to give you errors. But 0, -2 is where it starts. Then you have 1, -1, 4, 0, 9, 1. Menu, table, split screen. Menu, table, split screen. That's just a good way to make sure your graph moves the right way. Because if you thought the -2 was on the inside, you'd realize actually that was right 2. So good way to check your answers. Just go back and graph it. Down 2. So instead of 0, you're at -2. Instead of 1, you're at -1. Instead of 2, you're at 0, 1. So y equals the square root of x minus 2 on the outside.
Chupapi Muñano. Chupapi Muñano.
Reflecting your points over the x-axis, remember that changes the signs of your y. So 0, 0 is going to still be there, but 1, 1 will turn to 1, -1. 4, 2 will go to 4, -2.
Now I know what's real, what's cake.
What's your equation look like? Where would the negative be for reflecting it?
It would be it would be in front of like the A right there.
So negative square root of x.
Dude, I actually got it. I just have problems with the vertical stretches and stuff.
Right 2. From 0, 0, I take that point and move it right 2.
Are we almost done with those?
Almost.
No, like I have to go do something. I have to talk to the coach about something. That's why I'm wondering.
So instead of 0, 0, 2, 0. Adding 2 to your x values.
Now I know what's real, what's cake.
How do you write your equation? Or right 2?
I got this one.
Radical x.
Okay. Okay.
Minus 2. Yes. Radical x minus 2 on the inside. And why that is, just to give you a long explanation, is because your transformation equation is negative. So you're technically plugging in a positive 2. So that's why it's moving right 2. If I plug in a negative 2, it's going to look like a positive. So that's why it's going to be moved to the left.
Street run. Street run. Yo, what's going on right here, guys? What are y'all texting about? Is this something the class needs to know? Yo, Brayton.
Is that a 7?
Yes.
Brayton can take a smack.
So vertical stretch, vertical compression goes in front of your function. This function is a square root of x. And you're multiplying your y values by 3. So 0, 0, 1, 1 becomes 1, 3.
QT. More than a gas station.
4, 2 becomes 4, 6.
QT. More than a gas station. The fitness gram pacer test.
And that's all it fits on your graph.
Now I know what's real and what is cake. Got to sleep but stay awake. Oh shoot, oh shoot.
And then multiply a third. So 0, 1/3,
Miss Rose.
2/3.
It's
Yes,
like
sir.
the wheel
3/3.
came off. Miss Rose, this wheel came on.
Pull back.
Wheel just came off.
Put it back.
I just want to let you know.
Keep it.
Can I keep the wheel?
No.
Why fo?
You couldn't make wheelies with that.
Heelys.
You guys go ahead and try absolute value. I want to see what we're getting stuck on. Are we getting stuck on the equation or the graph or the table? All right, to slow down writing the equations, just a little bit. You're looking at an absolute value transformation. So if you're going to go up 2, it's not going to have a reflection. That's a reflection over x-axis. It's not going to have a stretch or compression, so that's going to go away. And it's not moving left or right, so that goes away. So your equation y equals absolute value of x up is +2. So that's the slower way to writing an equation. So on the outside of your absolute value, +2 to go up. On the absolute value of your equation, outside of your equation, down 2. To reflect over the x-axis, you put a negative in front of your absolute value bars. Right is inside. You go right or left on the inside. Opposite of what you think. Right is actually -2. Left is +2. Inside your absolute value bars. Vertical stretch, the 2 is in the front. Vertical compression, the 1/2 is in the front. -2, -1, 0, 1, 2. Absolute value marks make everything positive. Absolute value is a V. V for value. Absolute value. And then the easiest way to move your absolute value is just to move your vertex. So if you move your vertex 2, then it goes up to the right and to the left. That's nope. That was right 2. We're going up 2.
You're pretty loud.
Taylor.
All right, what questions do we have? Does anybody want to see the table for these? You want me to write the tables out? I can. Some in my last class were using the table every single time. That's fine. That's good. I definitely suggest using the table for vertical stretch and vertical compression. I'll always show you the table for this. But when you're just taking this graph and moving it right to, you're literally just taking each of those points and moving them right to. All of these should have arrows on it. Left to. Vertical stretch. So instead of 2, you multiply that by 2, you get 4, 2, 0, 2, 4. Should be skinnier. One half. Instead of 2, it's 2 times a half, so it'd be 1, 1 half, 0, 1 half.